Hi friends, welcome to the Unit 6 Day 1C. You see I've actually covered up the top part of these notes, and that's because check right now, see how many of these perfect squares you know, just off the top of your head. Don't look at your other set of notes. I believe in you. You can do it. Ready, set, pause the video. Go. All right. Now that you have those done, let's see how well you did. All right. 100%? Way to go. That's awesome. I'm glad you got 100%. Good job. All right, so warm up here. Simplify each of the following. You've done these before. We've actually done these already. So the square root of 8, you know this. Wait, have you had a chance to do the warm up yet? No? Okay, go ahead and pause the video again. Do the warm up, and then we will come back. In fact, you can also do warm up part 2 if you want. You overachiever, you. All right, so the square root of 8 we know is actually 2 times the square root of 2. We know that because the perfect square we can take out of 8 is 4, and we're left with 2. And the square root of 12, we know that that's 2 square root of 3. Excellent! You guys are doing great today. And then square root of 20, we know that that's square root of 20? Is it? Can I take any perfect squares out of square root of 20? 5. Excellent. Okay. So then we have 2 square root of 5. Yep. Good job. Good job. Square root of 24. Yep. And that's going to be 2 square root of 6. Okay. Yeah. Good job. Good job. All right. And then when we simplify each of the following here, 3x plus 5x, 8x, 5y minus 8y, negative 3y. Notice that these have to be exactly the same to be able to combine. As soon as we get to here, it's just 2 plus 10z. We can't combine them. They're different. This one, got to be careful. Those x's, got to be careful with your x's. 5x, and then 7y minus y, so that's 6y. There we go. Now that we have those, we can talk about what we do when we add and subtract radical expressions. You can only do it if the radicand and the index match exactly, similar to when we have these variables here. It's not exactly the same because they're different concepts, but it's similar. And then when you just add or subtract the coefficients. So for this one, for this to work with number 1, it says add or subtract each radical expression, circle your final answer. Hopefully I remember to actually circle this time. So here, this part here has to be exactly the same to be able to combine it. It is 3 square root of 5 plus 7 square root of 5. So 3 and 7 is 10 square root of 5. So a lot of students get this confused because they're still in the mindset of multiplication. Try and keep them separate in your brain. One's adding and subtracting, and this is and then one's multiplication. So today we're just doing the adding and subtracting part. So 6 square root of 2 minus 4 square root of 2. Again, these two are exactly the same, so we can combine them. So we get 2 square root of 2. This one here, same thing. These have to match. They do. That is square root of 7. So 18 minus 26 is negative 8 square root of 7. All right, down here. Things are a little bit tricky. Square root of 5 plus square root of 5, that is the same. The coefficients in front are 1, so 1 of something plus another 1 of something is 2 of that thing. So that is a good way to remember. And then here, 4 square root of 3 plus square root of 3, we get 5 times square root of 3, or 5 radical 3. All right, now here, remember, there's a 1 out in front. Those two match. 1 minus 7, negative 6. Radical 13. I don't know where 7 came from. Oh, I must have been looking at that bit. I apologize. So far so good. And then, oh, wait. These aren't exactly the same, but maybe they will be, because we know we can actually simplify square root of 50. We did that in the other set of notes. So when we simplify square root of 50, remember the square root of 50 we simplified because 50 had 25 as a perfect square and 2. So we simplified square root of 50 to actually being, what is that? Square root of 25 times square root of 2, which is 5 radical 2. Is that right? 5 radical 2, yeah. So square root of 5 minus 5 radical 2. Is that it? 25, 5. Yeah, okay. So now we can check and see, do these have the same terms? No, they don't. So then we are done. So that is it for that one. So you do have to be mindful. We do have to see if these simplify down. They might actually simplify down, and then we can be able to subtract them, or add them, or combine them. That's a better word to use. Square root of 27. I have a perfect square that I can take out of there. That's going to be 9. And then 75 is going to have 25. Now, a way to tell that you're going to be able to combine is if the leftovers have the same radicand. And so here I can see that this is a 3 and this is a 3. So I know at this point that these two will actually combine just because of what I'm checking here. And that's a cool way to, that's why we do it this way. It's another way to check. Oh yeah, it does work that way. So square root of 27. I like to actually simplify it up here. So the square root of 27 is equal to square root of 9 times square root of 3. And we know the square root of 9 is 3. So that's going to be 3 radical 3. So here we have 3 radical 3 plus, and then for this one, I'm going to do the same thing with 75. So that equals square root of 25 times square root of 3. I'm going into the next problem. 5 square root of 3. So 5 square root of 3, and then when I combine them, I'm going to use a different color. 3 and 5 is 8 radical 3. There we go. So that's how we do that, and we can combine them. That's awesome. All right, for number 9, we're going to do the same thing. We have 6 times radical 24, so we're going to simplify radical 24. Didn't we already do that? I felt like we did that earlier. We did. It was 2 times radical 6. So that means I can kind of skip some of this because we've already done it on the front. So 6 times 2 radical 6. I'm just jumping to that part because we have the front. So that's going to be 12 square root of 6. And then now we have this plus square root of 48. So plus square root of 48. Well, can we take a perfect square out of that? Let's find out. Let's see. 48. 16, maybe? Maybe. And 3 left over. Sweet. There we go. So that's going to give me, yeah, making sure. So that's going to give me, let's see, square root of 16, because 16 is the perfect square. Square root of 3. Plus 4, square root of 3. And it looks like I can't combine these anymore because this has the 6 left over, and then this has the 3. So I am done. Here, I am done. All right. Number 10. All right, so let's see, 44 and 99. Let's see, 44, large perfect square, 4. Any others? No, I think that's it, because then that's 11. And then 99. It's going to be 9 and 11. Oh, I see I'm going to be able to combine these because I got this here. It's always wonderful to see that because you can see like, oh, what's going to happen with this? So I'm bringing down everything on this next step. So I brought down exactly what we would have because we're keeping the radicals, the radicals. So then this is going to be 2 times square root of 11 minus 3 square root of 11. 2 minus 3. It's negative 1 square root of 11. We don't need the 1 there. We just have the negative. That's fine. So negative square root of 11. Next one. 4 times square root of 98 plus 6 times square root of 32. So I'm going to do these off to the side just because I'm afraid I'm going to run out of room. So 98, I think that's 49 and 2. And then 32 is going to be 16 and 2. All right, look at that. These are going to simplify too. So when I write these, I have to be really careful because of that 4, that coefficient, that 4 and that 6. I want to carry that 4 and that 6 with me as well. Show off my Bearcat shirt. Go Bearcats. So we've got 4 times square root of 49 times the square root of 2 plus 6 times square root of 16 times square root of 2. So now I can simplify 4 times 7 square root of 2 plus 6 times 4 square root of 2. Ooh, got some more simplifying. 4 times 7 is 28. So I have 28 square root of 2 plus 24 square root of 2. So now I can combine those. 28 plus 24 is 52. square root of 2. There we go. So now we got number 12, 15 times the square root of 208. So we've got 208. Let's see, what is that? 64 maybe? I don't feel confident with that. Nope. Wait, that was if I put in the right number. Nope, close. Let's see, what else we got? 208. 16, there we go. 16 went into it. And what do I have left over? 13. 13's a prime, so that's good. All right. And then 52. Let's see what that is. That's 4. With 13 left over. There we go. So again, just like we did on this previous one, we have 15 times square root of 16 times square root of 13 minus square root of 4 times square root of 13. Now you can combine them. 15 times 4 times square root of 13 minus 2 square root of 13. 15 times 4 is 60, so I have 60 radical 13. Remember, radical and root are the same, and we're using the same in all of this. We're using a square root in all of these. 16 minus 2 is 58, so I have 58 radical 13. There we go. All right, I'm actually going to stop the video and finish the last 5 examples in the next due to time. I will see you in the next video. Bye, friends.